We're good to go. It's all right. Thank you so much. Good afternoon, everyone. Thank you for joining us. I'm Karen Rege. I am the Dean of Online Learning and Media Services for the Community College of Philadelphia.
And I'm Jodi List. I recently joined Arizona State University with the Learning Engineering Institute as a research professional.
And we met up through a group called Icicle, which we'll tell you a little bit about at the end. But first, we want to talk a little bit about learning engineering today. Go ahead with the next slide. And so we want to know, have you heard about learning engineering? This is a brand new field. So we're going to start you all off with a little poll here. We'll give you a minute or two to take a look at that QR code or the link, whichever you prefer, and answer our little question. And then you're going to have to jump out of this to get to. Yeah.
Yeah, let's get out of this mode so we don't have to show the chat like this.
Yeah, you got it. Well, that's definitely needed.
Yeah. Are we on this? Are we on? Here we are. I was going to try. Oh, great.
All right. Ooh, I love this. Lots of what is it? Good. Well, we'll help you out with that today. No longer a mystery. Okay.
Great. Yeah.
All right. So to the next slide. So we have to confess, we had our slide deck made, and then we got to the plenary session this morning and had to do some updates. So we will post the newer version of the slideshow up on the platform so you all can have it. But we were really inspired this morning because of the work that's being done around the whole concept and around Quality 360. So learning engineering, is this new or old? The term was actually coined in 1967 by Herb Simon of Carnegie Mellon Institute. And so it's been around for a while as a term, but it's really starting to coalesce as a new field of study. It's so new, in fact, we've only had 3 conferences. How's that? But what we saw this morning was that this community around quality matters is really starting to have an emerging focus on the whole learner, the learner as the human, and this concept of Quality 360, which has people, communication, policy, support, processes, and evaluation. And that's a whole lot of what learning engineering is about. So, thank you. That didn't work. The mouse didn't work. You're going to have to advance a slide. Sorry. There we go. So here's what we're going to talk about today. We're going to go through some of the steps in the learning engineering process. We're going to talk about learning engineering as a team sport and how you play that game. And then along the way, we're going to have you develop an action plan for some sort of learning engineering you might be able to do at your own institution, hence the handouts. And I know Jim's posting the link for those of you online, so you can follow along with the handout as well. We're going to give you some theory, but we're going to also weave in a case study from the Community College of Philadelphia throughout the presentation so you can see how learning engineering is actually applied in the field. And we have lots of slides, so we're going to move very quickly so you can understand the whole process, but we also want to leave time at the end for questions. So I'm going to let Jodi start with a little story though.
So we're going to start with the differences and similarities between research, science, and engineering, because we're bringing in these types of terms into the learning environment. So what it really is the connection. And so our story starts back in 1928 when Alexander Fleming discovered penicillin by accident through discovery. What's your hypothesis? What are you thinking about? What are you trying to do? But he actually discovered it by his own exploring part of the whole science part of things. And then, you know, World War II came around in 1940 and people started realizing, oh my God, this is really serious and we need more of an antibiotic and we really want the penicillin. So we went from the science of it, what's it all about, to some research defining it. And so some other scientists were like, well, this is great, but how are we going to be able to scale it? It's World War II, lots of injuries, lots of people who need this type of antibiotic. So this is where the engineering part comes in, where you need to start thinking about logistics, you need to start thinking about chemical engineers, you need to start thinking supply chain, you need to start thinking of production. So that's the scaling part when we talk about engineering. And so what happened was there were some other scientists who got together with some American scientists, and by 1942, there was actually 400 million units produced in the year, but by 1944, there was 650 billion units of penicillin produced each month. So you can tell we went from the, again, the science to the research to the science, you know, to the engineering to scale it. And that's how we are talking about this. So the goal of science is to discover the truth, and the engineering is to create these scalable solutions. And that's where we're bringing in the learning as part of this. So we said that science is one tool, and these are other tools that you are already familiar with, including obviously most of you are instructional designers, you teach, you're faculty, you're familiar with the ADDIE processes or other processes in terms of putting together your coursework, you know, incorporating all the great QM standards and all of that type of work. Since many of you are also the teaching and putting together this curriculum, you have the learning sciences, which are enabling people, how do people learn? And including all of those things like a scaling and scaffolding and all these different other types of programs and tools. And now, of course, we also have the data, which is growing by leaps and bounds. And we're really starting to think about how do we measure student success? How do we see how people are doing? All the great things that QM is trying to work on in terms of creating really good learning experiences. So we have all these different tools to bring it together that compose of learning engineering. And this brings us to the definition. Karen had mentioned that we're together in a group through the IEEE called ICICLE, Industry Connections, Learning Engineering. And this is a definition that we came up and we produced a book, Learning Engineering Toolkit, and have these different components within the definition. So we have a practice and a process. We have that uses human-centered design with the learner at the center. We have engineering methodologies that we just discussed. And then we have the data, which we also did, and it's to support their learners and development. So we're bringing all of these components together, as we again said this morning, all of these different areas that we're working toward to making this a very holistic whole process. The steps, again, we just, as I just said, it's a repeatable process, and we want to iteratively design, test, and adjust and improve conditions for learning. So it's not just the one stop, which again, I know all of you are familiar with, being involved in so many quality assurance type things through QM. And then this is our process.
So just a quick show of hands, how many folks in the room are instructional designers, by the way? All right, so we have a few folks in the room. So many of you know all other models for developing instructional design. ADDIE is one of the big ones, and you'll see some similarities here. This is the actual full model, and we're gonna break this down for you in ways that make it a little more understandable. It was developed, the model itself was developed by Aaron Kessler from MIT and Jim Goodell from KIP, which is a company that actually processes the NCES data. And so you'll notice some similarities here between the ADDIE model, although some of the major differences are the A gets broken out and to include a whole lot more around the learners and their context. And then the 2Ds are kind of collapsed and combined into one longer multi-part step called creation. And you'll also see a focus on human-centered design, learning sciences, and a deeper, more intentional use of the data. So we're going to break it down and go through each of the steps for you. So the first one, again, you're going to start with a problem just like you do with the ADDIE model that's associated with learners or learning. The difference is it's not just about the curriculum, it's about making sure that learning is happening. not just looking at the final outcomes, but using the data to go into a deeper understanding of where the challenges are in the learning, and to really take a holistic look at the context of the learner. So Jodi's going to tell us a story again.
As you can tell, we really enjoy trying to make sure that the concepts are understood, as all of you instructional designers and faculty know. For the action plan, we're talking about steps 1 and 2 on the action plan, and we'll give you some more time to reflect, but if you just want to look at 1 and 2 as we move forward, that's where we are right now on the action plan. So as you saw by the process, there was about learners, it was about team, and about context. And the context is not necessarily just about, the environment in a classroom. This is the environment of how kids get to school. And I know there's some colleagues in the room who will appreciate this. And it's based in the Gambia in West Africa. Several years ago, they got rid of school fees for kids, younger kids to be able to go to school, but 30% of the kids of that age weren't able to get there. So they're like, well, what's the problem? Why aren't these kids showing up at school? And they were 3 to 8-year-olds in particular, but there was a 3-kilometer walk to get to the school. And parents didn't really like that very much. So donkey carts are still used, roads are still like that. There's lots of still dirt roads and stuff. And donkey carts are used to transport goods. So like, well, let's transport even these kids. So they designed this cart. The initial cart was a little bit heavier, not as designed as well. It didn't have the separate seats. It didn't have grab bars. So iteration, they designed it. They figured out, oh, it's too heavy. We need to make it lighter. Oh, the kids are sliding around. We need to create separate seats. We need to create more safety things. So it was an iterative design. So the context can involve anything around the whole learning environment, and it can take place in many different ways. So that's just an example of the context for learning engineering.
So we're going to actually give you an example of that in the higher ed context. So at CCP, when I first came on, my provost asked me, post-pandemic, can we implement HiFlex? And so if anybody in the room has implemented HiFlex, you'll know how challenging it is. First, it takes a lot of technology, and that's rather expensive. But the big lift really is around faculty and faculty professional development or training. So the faculty need to change some of their pedagogical strategies to be able to accommodate the learners in multiple modalities simultaneously in the classroom, and to fluently use the technology that they may not have used before, like a PTZ camera or a pan, tilt, and zoom camera, which is like the one we have in the back of the room so that our friends online can see. So that was our challenge. So most of us have some instructional design experience. So we thought, okay, we can go ahead and do that and design some training around HiFlex for faculty. And I know a number of you use regularly very clearly defined processes for developing online courses or curriculum. We saw some great examples of that earlier today, even where people were having an actual mapped out process and a checklist of how to design, right? We also know that some of the most effective designs come from teams. So I'm sure many of you have had your instructional designers pairing off with your faculty, but what about an entire team, right? Doing some collaborative course design and formalizing that into a process as well. So learning engineering includes all of this, and the definition of learning engineering also has a few other pieces to it. So as Jodi mentioned, it uses human-centered design, learning sciences, and data instrumentation that we need to focus on in the design phase itself.
I just see lots of chats. Are we okay on the chat, Jim? Okay.
All right, so we're going to talk a little bit about human-centered design here. There are lots of theories and principles. There's too much here to put into this presentation. So we're going to give you some resources at the end to help you with some of that. But we are going to show you some examples of some specific tools from human-centered design that we have used in developing our content and our online courses. And these include some stakeholder analysis, persona, user testing, things like that. So we really want to know who are we designing for? What's the context? What are their needs? And what are we going to design? And so these steps are, and these questions are usually answered both in the analysis phase and in the design phase. So going back to our case study at CCP, when we started looking at who we needed to design for high flex professional development or training for, we realized that we had faculty at all different levels. And so we created these personae. They actually look like the bottom on the slide here. It's a narrative, but because you probably can't read all of that, we made the top one bulleted just so that you can get a sense of the types of information that we were capturing very quickly. And we developed these because we surveyed the faculty on their technology skills and analyzed that data. And then we also looked at the literature for best practices. So we knew what some of the learning outcomes should be. And we tried to match that to the skills that we found from the survey that we had. And so from there, we were able to create these persona. So that's one way that we have used this human-centered design approach. And we also use faculty to do testing, to do beta testing. So as we are building, so that we can refine more quickly and reiterate more quickly. We know that learners are important stakeholders because they're who we're designing for. And so we need to include them throughout the process. All right, time to get active again. Another poll for you. So persona is just one of the human-centered design tools that we've used. Here are a couple of others. So we are curious to know, have you used any of these in your design processes? So we'll give you a minute here to jump on before we share the results.
It's the same link as before. Hopefully it works.
Did it take you to the next question? Okay, good, thank you. And there you go. Oh, excellent. Oops. No. More information than I would want. Go back. Sorry. So we have a lot of people with surveys. Oh, cool.
And then next is, you're still learning about HCD, which is exciting because you're gonna love it once you start using it. And then personas, lots of people have used personas. This is wonderful.
Great. Excellent.
Exciting. Yeah, lots of assessment tools.
All right. And I think at the next point, we're going to give you 1 minute just to reflect and to start to jot down some ideas you might have on your worksheet. So we're going to put a little timer on here and give you a minute of silence just to think through questions 1 through 3.
And 3 is the human-centered design.
The Google Doc you gave me, lots of people can type it, right?
Or they can download it and use it themselves. I think that was what we initially had intended.
No one's typing.
So hopefully, it was to be individual. So yes, please, if people download it and use it. Thank you. And thank you all for joining us online. We have 31 people.
Yay.
So we appreciate your interest and we're excited to start working and learning from you.
Okay, so we'll give you another chance to reflect a little bit later.
So as we said in the creation, we have several different areas that we look at as part of the process. We talked about human-centered design. Now we're going to talk about learning sciences. So how do people learn? And there's been lots of work done on that. In this case, these 5 different areas came from a lot of research from Pearson. They did quite a bit of work on learning sciences and on different ways that people were involved with learning. And they published some really great resources, and we'll share that link with you as well. And so when they looked at hundreds of different papers and articles on it, these were the 5 main areas that they came up with for the learning sciences strategies. So 1, learning is a welcoming experience. And we heard that this morning as part of the whole concept, where W was for welcoming. So again, all of these things that people have learned and are sharing together. So what motivates those learners and how to create those engaging experiences. The next one about purposeful outcomes focused design. So about the design, we want it to be outcomes focused, something that all of you are very familiar with. And then of course, to align those objectives with the learning activities, with the assessments, as many of you have done throughout this whole process with QM and instructional design. The third one is learning behavior. So we want to make sure that there's like nudges or metacognition for people to be able to take charge of their learning and apply what they've learned. Number 4, build how minds learn. So again, you want to make sure it's meaningful. You want to make sure it's authentic so that minds are interested and engaged. And then the last one, learning can happen anywhere. So how are you disseminating it? And you all are very familiar with the different ways of disseminating learning right now. For each one of these learning sciences in action, there's a lot of different strategies and methods under each one of those. And again, let's try to put the link in the chat. And there's a tremendous amount of documentation around each of those. So sticking to purposeful design, since we all do so much design, they focus on the objectives and assessment, everything that's evidence-based, personalized. And one of the speakers this morning in the keynote talked about the adaptive and personalized learning and authentic learning. So it's just interesting how they kind of organized it. And we just like this way. There's many ways you could slice or dice learning sciences, but this was just one way to capture it.
So here's an actual example of how we employed the learning sciences as we designed the professional development for HighFlex. So we intentionally scaffolded examples in our asynchronous modules that we created. And then we actually held practice sessions where the faculty had to teach in the HighFlex modality. We call those sessions application labs. We also engaged the social and collaborative learning part through teaching circles. And so the faculty were sharing activities that they had planned for the classrooms and getting feedback from their colleagues. And then we ourselves delivered all the training in the HighFlex mode. So the faculty were engaged asynchronously online, they were engaged face-to-face, and they were engaged asynchronously online, and they actually had their choice in most times to figure out how they wanted to attend. So we were trying to model what we were doing. We also added in a lot of self-reflection pieces for them. So we got into that metacognitive piece to having them talk and think about their strategies and how what they learned has changed their mindset around teaching. We also structured it in a way to prevent cognitive overload of having to learn both the pedagogy of how to teach in the HighFlex modality and using the classroom hardware and instructional software, which might be new to them. So for example, video editing and management, interactive polls, quizzes, and puzzles all at the same time as they have to manipulate the camera switches if they have multiple cameras in the room, making sure there's audio that's available and working fine, and they can engage the students who are online synchronously. So we have a lot more learning sciences resources that are available for you as well, and we'll share, again, some resources that are really helpful at the end.
And yet another part of the creation process, the data informed. A lot of these you're already familiar with, but it's a big part of learning engineering is really how do we find out if our challenge is successful? Is it improving the learning? Is it progressing? So how do we able to ensure to be able to do that? Well, first of all, when we design the content, we're designing the instruments to collect the data. We want to know from the very beginning what data we need to be able to collect to be able to show that. And that's a little bit different than what we've done in the past. A lot of times we may look at the data at the end to see how it's going on. But now we want to be much more aware of this iterative process of figuring out how do we want to show that the learning is taking place by designing these instruments at the beginning and determining where that data is coming from. So instrumenting all the data is an important aspect of learning engineering.
And that's actually one of Jodi's specialties. So if you have questions about data and instrumentation, ask her, not me. So here's a couple of ways that we did use data. We used multiple sets of data and we intentionally designed the instrumentation right up front. We've used a backwards design model in the asynchronous part so that we started with what the learning objectives were and built the assessments right away. We added in formative assessments in the form of quizzes right in the learning management system. We also added discussion boards to help them help the faculty who are learning to teach HyFlex, what the stickiest points might be for them. And that also helped us to inform the design. We did also a survey after they've completed the training to see what we needed to improve, if they felt comfortable with it before they got into the classroom. And then we used that data to reiterate on our design. Lucky for us, we did a pretty darn good design and the first time around and didn't have too much to reiterate on. But we also use self-reflection assessments in the training. And then we use a faculty survey after they've actually delivered the HyFlex course for the first time to help them figure out what worked and what didn't, and then to also help inform our training again, to see if there were any patterns that were coming out of that would allow us to reiterate on the training. All right, so we then had to implement, right? So we ran 3 HyFlex courses last spring, and then we really developed the training over the summer and delivered it over the summer to a cohort of about 10 more faculty. And then we implemented it even more fully. And we are now getting ready we're in the middle of training again for the spring 2024 semester. We had multiple iterations of this, and we ran into a couple of challenges as we were implementing. So that's one of the pieces in this implementation stage, is identifying what are some of your challenges and brainstorming ways to overcome them. We had a fairly long list, but in the interest of time, I'm only going to give you a couple of them. Some of them were related to things like budget. So our collective bargaining agreement requires that we pay adjuncts for the training, and we didn't have a budget in place. And then we have to figure out how to monitor, who's going to monitor and provide the feedback for the faculty as they're going through the asynchronous portion of the course. And another one that we had was just the sheer scalability. So right now we only have 1 instructional designer and we have almost 900 faculty on campus. So we are going to have to make the case for another instructional designer fairly quickly if we want to scale. And right now our goal is to scale to about 100 courses over the next 5 years.
And the last component as part of our definition, remember, it was about human-centered design, it's about engineering, it's about the process, and it's about the iterative data decision-making process. So that's where we are right now. And you can see that there's arrows going in every single direction, back and forth, all through it. It's not in one direction at all. And that's why we're saying it's such an iterative process, because we keep learning about how to keep improving these learning experiences and all the different ways that people are trying to do those approaches. Basic steps, which again, I'm sure many of you are already familiar with. As we've already said, design the instruments to collect the data from the very beginning. You're collecting it, you're analyzing it, and then you're making decisions and applying and improving upon that. It's 4 little steps, but they're huge and they're massive and they're complex and they're sometimes a little bit scary, but it's something that we're all learning how to do.
So I've already mentioned a few of the ways that we have collected data, including those self-assessment, self-reflection assessment data. And we also added a few things like focus groups with the faculty who actually taught in the first pilot. And I mentioned also the survey of those who had participated in the training, and then we redesigned. One of the other data points that we're looking at is actually our student success outcomes. So we're comparing, for example, in a pre-calculus class, we're comparing the midterm final and final exam and the final grade distribution compared to the face-to-face of the same class. So 2 sections that are being run at the same time. And then we're also looking longitudinally to over what happened this year versus last year. So we have different ways that we're looking at that data, including the student success outcome data, as a way to see if we are actually meeting the challenge and our learners are learning what we're asking them to learn.
And then the other part included in our definition was engineering methodologies. And so we thought this was a great way to sum it up, because if you look at it, engineering, these are some of the techniques that engineers use. It's practical applications. That's what we're doing. We're trying to create these practical applications when we design our learning experiences and how they can be applied. It's outcomes focused. We're trying to solve real world problems, obviously within our learning. There's instrumentation and measurement, and we're always trying to do continuous improvement. So these are basic engineering techniques that we're using and applying more and more to the learning process. So as we started with, learning engineering is not necessarily a new concept. It was said by Herb Simon, who was the president of Carnegie Mellon and won some Nobel Prizes and is an AI person, said this in 1967. And it's a process that many of you probably already use in different facets and different ways, but may call it something different. And especially with instructional design now, we know how much instructional design strategies are included so much more than the initial things that many of us learned about, including myself, 15, 20 years ago. So it just keeps evolving. So many of you probably already are learning engineers, but just never called yourselves that. So we really look forward to learning from you and moving it all forward.
So I think we're going to give you 1 more minute to reflect and work on questions 5 and 6 on the worksheet.
Click on chat for a second, just to make sure we're all good. No. I'm gonna copy this.
Okay. All right. So the last part, as I mentioned at the beginning, learning engineering really is a team sport. And so who do you need on your team? A few years ago, we had, actually in 2019, we had the first Icicle conference, learning engineering conference. And in that conference, we had pretty much defined what learning engineering was, but we were trying to define what a learning engineer was. And there was a lot of heated discussion, a lot of great minds in the room. And we ended up settling on learning engineering as a team sport, but a learning engineer is someone who in all likelihood has a base knowledge of some common competencies and shared vocabularies for the practice of learning engineering and having different roles and expertise. So a learning engineer is someone who is general and then has one of these subject area expertise. But again, we have subject matter experts here. We have learning sciences. We have folks who are doing assessment and measurement, data science, software engineering, user experience engineering was really important. Education and training professionals, because part of our group includes not just higher ed, but also government, military, K-12 and publishers, ed tech companies. So it's a very wide variety. So there are folks who are doing not just learning like we know it in higher ed or K-12, but actually training. And then of course, our instructional designers.
Just a comment about this. If you're in a learning engineering team, you will have a set of competencies across all of these areas. It will be a basic set of competencies, but you will need to know certain things in almost all of these different areas. Versus if you're more of an expert in, doing data science, obviously, you're going to have those expertise in more formal and more intense competencies. So we're actually currently working on our competency framework and really thinking about, okay, what are those different competencies about? Our action plan.
All right. So this is sort of a summary of the learning engineering process. And we hope that your handout and your action plan will include all of these and will get you thinking through some of these as we go along. And then finally, we wanted to leave you with some resources. So here's a handy little one-pager that talks about learning engineering at a glance, which you can find on the Icicle website. So the link at the top is the Icicle website. We do have monthly calls each Wednesday of the month, each third Wednesday of the month at noon Eastern time. And there are people literally from all over the world and from all different areas that work with learning who join the call. It's different every month and there's different speakers. There are also a number of special interest groups and market interest groups, including designs, and Jodi's got one around competencies. There is one for higher education, and they meet on different days of the month, and that's where the real work happens. Again, we've had 3 conferences so far. The next conference will be in the end of July at Arizona State University. And so if you're interested in joining and getting involved in learning engineering at all, and Icicle, let us know. And then finally, our sort of Bible is the book that we published and released in 2022. It's called The Learning Engineering Toolkit, and it was authored by Jim Goodell as the primary author, but we have one of the co-authors here with us. There were a number of co-authors of the book. It is a wonderful mix of all the theories that we've talked about today in depth, as well as practical applications and case studies. So you can buy it online, Amazon, or anywhere that you normally buy your hardcover materials. I don't know if it's come out in digital format yet. It's just,
not yet.
It's still hardcover.
We're working on that. We're trying to at least make the first chapter available. Publishing, you guys know how publishers are. So yeah, we just want to thank you for joining us and all the people online. So this is really a systems approach, right? We're not thinking about one area or another area. We're trying to bring all of these areas together to create the best possible learning experiences. So we look forward to working with you. And again, the Icicle, if you just type in then 3 E's, icicle.org, that will get you to the website. So 3 E's, IEEE, Icicle, like your Icicle, .org. And at the bottom of that screen, you'll see a link to sign up for our newsletter, or just let us know and we'll add it to you. You get 1 email a month to remind you about our monthly call. And then there's the list of all the different special interest groups and market interest groups that Karen just spoke to you about. Everybody's welcome. There's no membership fee. There's no obligation. Come when you can. Everybody's just welcome. So thank you so much for being here.
And I just want to thank you too. For me, it's been a really wonderful journey working with Icicle. I have learned so much. And we are really working on some cutting edge things with some of the greatest minds in the country. So folks who are major scholars in the areas that they specialize in, for example, learning sciences and design. So come and join the conversation. It's a growing field. As we mentioned, it's a brand new field. It's developing. So if you want to get in on something cutting edge that ties everything we've been talking about at the conference here together, then, you know, we'd love to work with you and create a deeper partnership between Quality Matters and ISO.
We have a lot of people who actually originally put SCORM together. So, yeah. I mean, some of those key people from Advanced Distributed Learning, I mean, they're regular contributors to all of this. So serious learning people.
So we can take some questions. We have about 8 minutes or so. Does anybody in the room or anybody on chat have questions for us? 4 minutes? Okay, thank you, Jim. 4 minutes. Boy, you left them speechless. We're in trouble. I guess so. Well, we'll be around the, oh, we got a question, go ahead.
Well, it's based a lot on what do you want to learn? What do you want the learners to know? Oh, sorry. The question is about instrumentation and designing the data instruments and designing what you want to be able to collect at the beginning. Is that correct? Okay. I wish one of our other colleagues was here because she has the perfect answer to it because she does it on a daily basis. And that's the tools. Special interest group. So I highly suggest you join our tools special interest group. It meets on the last Thursday of the month at 2 p.m. Eastern time. So it's basically thinking about, well, what is your challenge? How do you want to know what your solution will be? How do you know if it's progressing? How do you know it's succeeding? So it's from the very beginning. I mean, think about your learning objectives, right? I mean, how do you show that those learning objectives have been met? But it's not just at the end, but it's throughout the process. So all of you who are, you know, all of you are QM experts, online experts, you're devising like quizzes and other types of like knowledge checks in between. Additionally, you can use as part of the design of the courses themselves, the person who I would love if she was here, she works at Carnegie Mellon University. And so they use, the program they use, they have their own learning system. So you can note every single step of the way where there is an issue with the curriculum itself. So if there's problems that are being addressed or questions, Carnegie Learning is another, they look at every single little piece of data throughout the total learning experience. Duolingo has an incredible process as well. So Duolingo actually has some really nice examples because they do research on their tools and stuff. So it's really just thinking about as part of your design, okay, well, what data would be useful to find out if the learning is working, if the learning is taking place. And as you know, it can be about the course itself, it can be about the learners, it can be about lots of different things. Is that helpful? Yeah. Mm-hmm.
Yeah, to give a little more example of that, I think Jodi was talking about the OLLI platform. Is that what you were going at?
Yeah.
So if any of you know the OLLI, the Online Learning Initiative platform out of Carnegie Mellon, it's an adaptive learning platform that was developed in-house. It was homegrown, but they actually get into the analytics on the back end and they start analyzing question by question to see which questions most students got right and which questions they might have gotten wrong. And then they go back and look at how that content was delivered on the platform itself, and they reiterate on how they've designed that platform. Any other questions? Nothing online? Well, we thank you so much for joining us today. It's been a pleasure.
Thank you.